8.6 is our final lesson in this chapter, and this time we are dealing with solving rational equations and inequalities. So we've been talking about rational equations this whole chapter. We've been graphing rational equations, adding and subtracting, multiplying and dividing. Now we're actually looking at how do we solve a rational equation. So a rational equation, we've identified what rational expressions are, but rational equations are just any equation that contains one or more rational expressions. And again, rational equations can be more easily solved if you eliminate the fractions first. So we're going to go through and do that. So don't panic when you see, oh my goodness, we have to solve with fractions, because we're going to go through a lot of what we did with adding and subtracting. We're going to get the least common denominator, but then we're going to multiply through by it and really eliminate it, so we don't have to worry about doing fractions on both sides. So for instance, if we take a look at 9 over 28 plus 3 over z plus 2 is equal to 3/4. What we want to do is kind of look at what do we have to multiply by. So I'm going to rewrite this with some space in the middle, because we want to get this to have the LCD. So we want this to have the least common denominator. Well, this one isn't anywhere, so I have to multiply both of these by z plus 2. This one has to be multiplied by 28, and this one also has to be multiplied by 7. So notice this one over here, we need the z plus 2 over the z plus 2. It already has the 4, because 4 is a part of 28. This one just needs the 28 over 28. And this one needs both the 7 to make it 28, but it also needs the z plus 2. So when we multiply this, we get 9 times the quantity z plus 2 plus 28 times 3 is equal to 3 times 7 times z plus 2. Now notice, again, all of this is all over that same 28 times z plus 2. And same thing over here, because we made it so they have the same denominator. Well, if I multiply both sides by the denominator, if I multiply both sides by 28z plus 2, cancel, 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 and now we're just left with this. So then we can distribute the 9, so we have 9z plus 18 plus 84 equals 21z plus 42. And now we can solve for z. So I'm going to go ahead and move to another column here. So we have 9z plus 18 and 84 is going to give us 102. Is going to be equal to 21z plus 42. Subtract 42. So we end up with 9z plus 60 is equal to 21z. Subtract 9z, so we get 60 is going to be equal to 12z. And then divided by 12, so z is equal to 5. You want to look back at the beginning. If I plug z in, is that going to make this undefined? It's not, because it will stay positive and it won't be 0. So that is one thing you have to be careful of. And that's why they ask you to check your solution. Because if I plug this in, is this the truth? Is 9 28ths plus 3 over 7 equal to 3/4? If I multiply this by 4 over 4, it should get you the same answer. So all we're doing there is really getting them so they have all the same denominator. And then you eliminate the denominators and you just focus on the numerators. Just focus on the... Alright, as we look at this one, there is one thing, there's a typo in this problem. It should be r plus all of this. So make sure if that's not in your papers that way, make sure that you do have it as r plus that whole quantity. So we need to make sure we have the same denominator. So if I have to factor this denominator first, we're going to have r plus, and leave some space just in case, r squared minus 5 all over r minus 1, r plus 1. is equal to r squared plus r plus 2, that doesn't factor, all over r plus 1. So I have to multiply this side by r minus 1 over r minus 1. This one stays, this one has to be multiplied by r squared minus 1 all over r squared minus 1. It's that whole denominator we need to multiply it by, so we have the same denominator across. So we'll distribute that, so we get r cubed minus r plus this r squared minus 5 all over that denominator is equal to, and I'm going to distribute this across the top as well. So we're going to have r cubed plus r squared plus 2r minus r squared minus r minus 2 all over r plus 1, r minus 1. So I'm kind of doing both things at once. I'm worried about the denominator, but I'm also multiplying the numerator. So here we have r squared minus r squared, so those will end up canceling. Then we're just going to eliminate the denominators. Over here we're all finished. We have r cubed plus r squared minus r minus 5. And over here we're going to have r cubed plus 2r minus r is going to give me just plus r minus 2. So the r cubes will cancel. And then I'm going to move everything onto this side. So we're going to have r squared, subtract the r, so we have minus 2r, add the 2, minus 3 will equal 0. So now let's try to factor that. When I factor it, I end up with r minus 3, r plus 1 equals 0. So then we solve it. And those are our two values. However, what happens when I plug in a negative 1 to the original? If I go way back and plug in a negative 1 here, negative 1 plus 1 is 0. Can my denominator be 0? It cannot. So that one does not work. Because it's going to make the whole solution undefined. 3 will work. Because 3 squared minus 1 is going to be 8, and 3 plus 1 is 4. So 3 is okay. This is a solution. But you have to check that solution to make sure it's not going to make your denominator 0, which makes the whole equation undefined. So make sure to double check that when you are solving and getting your solutions. Alright, so a rational inequality. So first off, a rational inequality, the definition of it, is inequalities that contain one or more rational expressions. So it's very close to an equation. We're just using greater than, less than, or equal to this time. So step 1, state the excluded values. So the excluded values would be values that you cannot use because it's going to make the denominator 0. So we can't have that. Then we're looking at the related equation. So we change the greater than, less than into an actual equation and solve it just like we have earlier in this section, just like we did a minute ago. Then we use the values in steps 1 and 2 to divide a number line into intervals, test the values, and determine which intervals contain the ones that will satisfy the original inequality. So we've done some of that before. We're just applying it now to rational inequalities instead of inequalities of some other type. Alright, so let's look at this one here. So we have 1 over 4a plus 5 over 8a is greater than 1/2. So the first thing we want to do is get this, well, we want to say, okay, what is a not allowed to be? A cannot be 0. If a is 0, then we're going to have an undefined denominator. So this is our excluded values. So step 1, excluded values, a cannot be 0. Number 2, 1 over 4a. We need to get these to have the same denominator. So if I multiply this by 2 over 2, we get 2 over 8a plus 5 over 8a is greater than 1/2. Combine it, we get 7 over 8a is greater than 1/2. I'm just going to go ahead and change that into 7 over 8a equals 1/2. Now, what do I have to do? I have to get this to have the same denominator as this one. So I multiply this one by 4a over 4a. And I could have done this ahead of time, up here, I just forgot. So now when I come over here, we get 7 over 8a is equal to 4a over 8a. These cancel, so we have 7 equals 4a. Divided by 4, a is equal to 7/4. So now we take 0 and 7/4 and we divide it up into that number line that step number 3 talks about. So we have 0 and we have 7/4. And we're going to test all 3 intervals. So if I have a -1, so we come back here. If a is -1, we're going to have, so I'll go down here and I'll test these. If a is a -1, we have 1 over -4 plus 5 over -8, and we want that to be greater than 1/2. So we have, change this to -2/4, so -2/8 minus 5/8, we want to be greater than 1/2. This is going to be negative, which is not bigger than 1/2, so that part does not work. So now let's test one in between 0 and 7. Let's say a equals 1, or 7/4. So let's say 1. So I have 1 over 4 plus 1 over 8, and we want that to be greater than 1/2. So change this to 2/4. So we have 2/4, or 2/8, excuse me, plus 1/8 has to be greater than 1/2. That's 3/8, not greater than 1/2, so this doesn't work either. So we have one more section to try. So let's try a equals 2. So if we put 2, we have 1 over 8 plus 1 over 16, and we want that to be greater than 1/2. I'm sorry. This should have been 5 over 8. Changed it to a 1 for some reason. Sorry, so that is greater than 1/2, so this section does work. So that works. So now if I make this 5/16, and if I change this to 2/16 plus 5/16, that is not greater than 1/2, because 7/16 is not, so that doesn't work. So the interval is going to be between 0 and 7/4. Alright, your homework is 10 through 28, the even problems. Again, remember that your limit, you want to get the denominator so it's the same. You want to get it so it's the same, and then that way you're able to eliminate it.